Hi everyone, we're going to get started on chapter 3. And chapter 3 covers probability. I'm actually going to skip around a little bit in this chapter because I think it makes the information flow a little easier, so just bear with me. Starting with section 3.1, which are the basic concepts of probability. So we start with something called an experiment. Now this isn't some real fancy schmancy science experiment that we're talking about. We're talking about just an action or trial which specific results are obtained. So this could be like flipping a coin. That would be an experiment. Or rolling a die. Or drawing a card. Something that you do in which you have outcomes that can be recorded. So that takes us to our next definition, which is an outcome. An outcome is the result of a single trial of an experiment. So if I went back to the experiment of flipping a coin, an outcome would either be heads or tails. Rolling a die, it would be the number that I would get on the die. Then we have sample space. And the sample space is all possible outcomes of an experiment. And then an event is a subset of the sample space. So I'm going to give you an example and use all of these words to define parts of the example. Our example is going to be to roll a die. So that's the experiment. The outcomes would be the number rolled. The sample space, if it was a regular die with 6 faces, it is a set, so we're going to use set notation, and it would be the numbers 1 through 6. And then an example of an event, we'll call it event A, would be getting an even number and so the event A would consist of the numbers 2, 4, and 6. And again, that is a subset, so we're going to use set notation. So anytime you have an experiment, you can list out all the possible outcomes. And then if you have an event that's defined on that sample space, then it will be a smaller subset of the sample space instead of all the possible outcomes. There's something called the fundamental counting principle that will help you figure out how many possible outcomes there are in a sample space. And the way that you do that is to get the total number of outcomes in an experiment. Find the product of the number of outcomes of each level of the experiment. So, for example, if my experiment was to roll a die and then flip a coin. Well, there are 6 outcomes on a die and 2 outcomes on a coin. So there are 12 possible outcomes. So the sample space there, now that I know there are 12, that will help me not leave any out. I could get 1 in a head, 1 in a tail, 2 in a head, 2 in a tail, 3 in a head, 3 in a tail, 4 in a head, 4 in a tail, 5 in a head, 5 in a tail, 6 in a head, 6 in a tail. And that would be the sample space. And if you count them, there are 12 possible outcomes. Let's say my event that I want to define here is getting tails. Then that would be 1 in a tail, 2 in a tail, 3 in a tail, 4 in a tail. Make that look a little better. 5 in a tail, 6 in a tail. So I would have 6 possibilities out of my sample space that would be defined for that event. So that kind of gives you a breakdown of the difference between an experiment, an outcome of an experiment, the sample space, which is all the possible outcomes, and then an event, which would be a subset. Then, if I was asking you to find the probability of an event, then I would take the number of successes and divide it by the total number of outcomes. So if I wanted in this case to find the probability of event B, then I would have 6 out of 12. If I went back up here and found the probability of event A, it would be 3 out of 6, and you could reduce that. Probability can be written as a decimal or as a fraction. So we're going to talk about two different types of probability. There is what's called, actually we're going to talk about three types. There's classical or theoretical probability. And that is when each outcome in a sample space is equally likely to occur. And that can actually be calculated. So like we know the probability of getting tails on a coin is 1/2 because there's one tail out of two possible outcomes. The other type, or one of the other types, is experimental probability. Which is the number of observations obtained from an experiment. So if my experiment was flipping a coin 50 times and I got 47 heads, then 47 out of 50 would be my experimental probability. So it's actually what happens when you do the experiment. There is something called the law of large numbers. And the law of large numbers says, as an experiment is repeated a large number of times, the experimental probability and I would need to spell probability correctly there. Probably help. Gets closer and closer to the theoretical probability. So for example, if an individual flipped a coin 10 times, they might get 4 heads. They might get 7 heads. They might get 6 heads. And so that probability could have a wide range that actually happens in just 10 flips. But if we go to 100 flips or 1,000 flips, then we're going to get closer and closer to half of those flips being heads. So that's what the law of large numbers tells you. Subjective probability is probability that results from intuition, educated guesses, and estimates. So an example of suggested probability would be, or excuse me, subjective probability would be like the weather report. You have meteorologists that don't know exactly what's going to happen, but they use educated guesses, estimates, and intuition to give you a probability that it will rain tomorrow. Now, the last thing that falls under section 3.1 are the actual basic probability rules. The first one is that probability will always be a number between 0 and 1. So that means no negatives. Nothing greater than 1. And it can be written as a fraction or decimal or percent. The second rule is that the sum of all the probabilities involved has to equal 1. And then the third talks about what the complement of an event is. And it says the probability of the complement to an event is equal to 1 minus the probability of the event. Because the definition of the complement is everything not in the event. So, for example, if you roll a die and your event A is getting a number greater than or equal to 3, then event A, which has 3, 4, 5, and 6 in it, has a probability of 4/6. The complement to event A, you can use A with a prime. Here, let me write this below so that, A prime, A with a little c, A with an asterisk. Those all indicate we're talking about the complement. So the probability of A prime would equal 2/6 because it equals 1 minus 4/6. So that kind of tells you how the complement of an event and an event go together. Their total probability sum has got to equal 1. And then one of the biggest things that you need to remember is that the complement to at least 1 is none. So you'll see problems and it'll say, find the probability that at least one of these things will happen. Well, if you know the probability that none of them will happen, then you can calculate the probability of at least one of them happening. So that gives you everything that is in section 3.1. I'm actually going to move ahead to section 3.3 in the next video.